In this video, we're going to show a proof of the angle sum and difference identities. Once we know these, we can actually prove lots and lots of other trig identities. So the angle sum and difference identities I'm talking about can be written in the following way. We have cosine of either the difference of two angles or the sum of two angles, and then sine as the difference of two angles and the sum of two angles. You can see each of the four sum and difference identities here. Now, to prove these, we're going to focus on just one identity to start with. We're going to focus on cosine of beta minus alpha. And it says that cosine of beta minus alpha is equal to cosine of beta times cosine of alpha plus sine of beta times sine of alpha. Before we actually get into the proof, there's two important key concepts that we need. So the first is that each point on a unit circle is cosine of theta comma sine of theta, where theta is the angle from the x-axis to a ray going through the unit circle. The other key idea is the Pythagorean identity that says cosine squared of any angle plus sine squared of any angle is equal to 1. That comes from the fact that cosine theta sine theta is a point on the unit circle. So let's prove the cosine difference identity that we have here. The first thing we're going to do is we're going to look at a diagram of alpha, beta, and beta minus alpha angles, assuming that the beta angle is the bigger of the two angles. Let's say that the beta goes from the x-axis all the way to this ray, ending at point B. Alpha goes from the x-axis to the ray ending at point A. And beta minus alpha, well, it's going to be alpha degrees or radians less than beta. And so we're going to say that that ends at point C. Lastly, point D will be the point 1, 0 that lies on the x-axis. I've created a Desmos diagram for that. And you can see that as alpha gets bigger or smaller, then that will change both the alpha and the beta minus alpha. When alpha gets really small, let's make it smaller, then this distance and this distance are the same. So from B to C and from A to D are the same. That's going to be the case no matter what size alpha is. The key thing is that while the distance from A to D and B to the C are the same, that also means that the distance from B to A, so B to A, is going to be the same as the distance from C to D. So from B to A, no matter where we're at, B to A is the same as from C to D. So we're going to look at those two distances and calculate those two distances. That is the distance from B to A on this picture and the distance from C to D on this picture. Remember that points are determined by the unit circle. So A, since it was at the end of the ray made by angle alpha, is going to be the point cosine alpha comma sine alpha. B, since it's the point at the end of angle beta, is cosine beta sine beta. C is cosine of beta minus alpha, sine of beta minus alpha. And D is the point 1, 0. So we're going to set the distance from A, which we know is cosine alpha sine alpha, to B, cosine beta sine beta, equal to the distance from C to D. Let's take a look at the distance from A to B. Well, the distance is change in y values squared plus change in x values squared, all underneath the square root. So sine beta minus sine alpha squared plus cosine beta minus cosine alpha squared. When I expand those out, I'll get sine squared beta minus 2 sine beta sine alpha plus sine squared alpha plus cosine squared beta minus 2 cosine beta cosine alpha plus cosine squared of alpha. And this is where the second property comes in. Sine squared beta and cosine squared beta are going to add up to 1. Sine squared alpha and cosine squared of alpha also add up to 1. So sine squared of an angle plus cosine squared of an angle, sine squared of a different angle plus cosine squared of a different angle. We get 1 plus 1, which is 2. That will be the 2 we see here. And then minus 2 sine beta sine alpha minus 2 cosine beta cosine alpha. If we look at the distance from point C to point D, remember here's point C, here's point D. Change in y values is going to be from sine beta minus alpha to 0, square that, plus from cosine beta minus alpha down 1, square that. When we expand that, we get sine squared beta minus alpha. This becomes cosine squared of beta minus alpha minus 2 cosine beta minus alpha plus 1. That's what I get when I expand this expression. And then once again, we have a sine squared of beta minus alpha plus a cosine squared of beta minus alpha. Those combine to give me 1 because of the Pythagorean identity, and we have the same angles. So we get 1 plus another 1, that's a 2, minus 2 cosine of beta minus alpha. Now we're ready to set those two distances equal. 2 minus 2 cosine beta minus alpha underneath the square root is equal to 2 minus 2 sine beta sine alpha minus 2 cosine beta cosine alpha. And essentially, we can get rid of the square roots by squaring both sides, subtract 2 from both sides, and then divide both sides by a negative 2. And that's going to give us cosine of beta minus alpha is equal to cosine of beta times cosine of alpha plus sine beta times sine of alpha. That is the angle difference formula for cosine. In order to get the other 3 sum and difference identities, we just have to notice that cosine of negative of an angle is the same thing as cosine of the positive of that angle. Sine of the negative of an angle is the same thing as negative sine of the positive value of the angle. You can look at the graphs of cosine and sine and see that. You can also understand that cosine is an even function where sine is an odd function. The other thing, if you shift cosine to the right by pi over 2 units, you get sine of theta. Cosine theta minus pi over 2 is equal to sine of theta. And if you do sine of theta minus pi over 2, that's equal to negative cosine of theta. Again, you can look at the graphs to see that that is true. We have this cosine of beta minus alpha. If I replace alpha with a negative alpha, then what happens is I get cosine of beta plus alpha, and then I replace each alpha I see with a negative alpha, but we know how negative alpha works inside of cosine. That's the cosine of positive alpha. Here, since sine is an odd function, we take the negative on the outside, and we get the cosine of beta plus alpha identity. For the sine identities, Well, first thing I would replace the beta with a beta minus pi over 2. And if you do that, what happens is that this is cosine of beta minus alpha minus pi over 2, which is sine of beta minus alpha. And then cosine of beta minus pi over 2 is sine of beta. And sine of beta minus pi over 2 is a negative cosine of beta. So we get our sine beta minus alpha identity like that. And then if we replace this alpha here and this sine of beta minus alpha identity with a negative alpha, we get the cosine of beta plus alpha identity. And you can see how that works here. So that gives us all four sum and difference identities. Now all four of those identities have been proven and shown to be true.